students, today we will discuss about the hydrocarbons. If we divide the word hydrocarbon, then it will divide into the hydro and carbon. It means it consists of the carbon and hydrogen only. And these are example are methane, ethane, propane, etc. There are two type of the hydrocarbon: saturated hydrocarbon, unsaturated hydrocarbon. Saturated hydrocarbons. Those hydrocarbons which contain single bond. Those hydrocarbons which contain single bond only are called the saturated. Saturated means single bond. SS, saturated single bond. And example is methane, ethane, propane, butane, pentane, hexane, and so much. Unsaturated hydrocarbons. Those hydrocarbons in which valency of the carbon is satisfied by the double or triple bond are called the unsaturated hydrocarbon. Example: ethene, ethyne, propine, propene, butene, butane, etc. Now these hydrocarbons are divided into three types according to the bonding: alkane, alkenes, and alkynes. Alkanes. Alkanes. As the name shows, alkanes, anes, they have the suffix anes. Anes, they have the suffix anes. Ines, they have the suffix ines. And they show the single bond. They show the double bond. They show the triple bond between carbon and hydrogen atom. Formula of alkane is CnH2n plus 2. CnH2n plus 2. Alkene's formula is CnH2n. Alkyne formula is CnH2n minus 2. Here n is the counting number of 1 to 9. If we put the value of 1, 2, 3, 4, 1 to 9, then they form the formula methane, ethane, propane, butane, pentane, and hexane. Now methane. Methane CH4. It has the chemical formula CH4. Carbon share 4 valence electron with the 4 hydrogen. Ethene C2H4. Here carbon showing double bonding with the other carbon and share 2 valence electron with the hydrogen. Ethyne. Ethyne C2H2. Here carbon share triple bonding with the carbon and 1 electron with the hydrogen. Now what is functional group? It is the atom or group of atom or relative part of compound which largely determine the chemical properties of a compound. This group of atoms determines the chemical properties of a compound. Here are the 4 functional group in the 10th class. OH, alcohol, CHO, aldehyde, C double bond O, ketone, C double bond O, OH, carboxylic group. Homologous series. It is a series of the compound which are derived from the same general formula, having same functional group, similar chemical properties. Homologous series has same general formula, same functional group, and similar chemical properties and show gradation in the physical properties. Each member differs from the successive member by the CH2 group. The difference in the molecular weight between the two successive members is 14U. Now what are the characteristics of the homologous series? They have same general formula. They have same functional group. They have similar chemical properties. They show gradation in the physical properties like melting and boiling point, increase with increase in the molecular weight. Now IUPAC meaning. IUPAC full form is International Union of Pure and Applied Chemistry. Now what are the rulings for the IUPAC naming? Rules are: select the possible longest chain. First select the longest possible chain. You can select here 1, 2, 3, 4, 5. This is the longest. But here the functional group is here. This show the alkene double bonding presence is there. That's why we will starting from the functional group first. The number of the carbon atom in the parent compound is denoted by the proper prefix. Proper prefix. Parent chain contains 6 carbon. If this contains the 1, 2, 3, 4 carbon, then it is methane, ethane, propane, butane. Methane, ethane, propane, butane, then butane. But due to double bonding, it is butene. And if 6 carbon is there, then we can say the hexane. Group attached to the parent chain are indicated by their names and prefixing the number of carbon to which they are attached. Counting of the carbon chain is done in such a way that the carbon attached the alkyl group or functional group get the minimum number. We can mark from here 1, 2, 3, 4, but here the functional group is at the third position. But if we started here, then the functional group is at the first position. If more than one identical group are attached to the carbon atom, these groups are indicated as di for 2 and tri for 3. If 2-methyl group is there, then according to the numbering, at 2 position methyl group is present, 3 position methyl is present, then we can write here 2,3-dimethyl butane. Methane, ethane, propane, butane. If we mark the UPSC naming here, then first select the longest chain. 1, 2, 3, 4. If we select it 1, 2, 3 short chain, 1, 2, 3, 4. It is the longest chain and this is also the longest chain 1, 2, 3, 4. But if we write 4 here, then methyl group is here at the same position after the third. That's the 2, 3 methyl. And methane, ethane, propane, butane. Butane is there and 2, 3 dimethyl. 2, 3 dimethyl. For double and triple bond, suffix "-ene" and "-ine" is used. Just starting from the here, first select the longest chain 1, 2, 3, 4. Now see the functional group and here we see that functional group is in between 2 here and 2 here. Methane, ethane, propane and butane. First is butane, but due to doubly bonding it is butene, and "-ene" is this functional group is light at the position of 2. Then we can write but 2 ene. Now alcohol. Alcohol has the functional group OH and write the suffix -ol. If we take the methane, then methanol. If we take the ethane, then replace the E with the O, ethanol. Methanol, ethanol, propanol, butanol, pentanol, hexanol. All these are the alcohol. Now we write the name of this formula. First C3. Write down 3 carbon at first and now write down the functional group on any side and then satisfy the valency with the hydrogen. And here 1, 2, 3, 4. 4 carbon, 4 tetravalency are satisfied of this carbon. 1, 2, 3, 4. And here also the tetravalency of carbon satisfied. 1, 2, 3, 4. And tetravalency of this is satisfied. And hydrogen should be 7. 1, 2, 3, 4, 5, 6, 7. Now write down the name 1, 2, 3. This is the longest chain. At first position, ol group. And if we write down the propane, this E is replaced by the OL, propanol. Propanol 1. At one position, functional group is there, then 1 propanol or propanol 1. Next functional group is aldehyde. Functional group is CHO. And for ketone, C double bond O. And if we write down the naming, then at the end of the methane, E is replaced by the ul. Al, al. This is this is the aldehydic group. Aldehydic group. Now first select the longest chain 1, 2, 3. Methane, ethane, propane. Now propane. Replaced E by al. Propanal. 1 propanal or propanal 1. Now ketones. Ketones have the functional group C double bond O and write down the suffix 1. 1. That is, now we will write down the name of this compound. First select the longest chain 1, 2, 3, 4, 5. 1, 2, 3. The functional group is at the same position on both the sides. So we can write anywhere. And longest chain is 5. Methane, ethane, propane, butane, pentane. Now write down pentane and at the third position, there is the functional group 3 pentane. Replace E with the ONE, 3 pentanone. Fourth group is carboxylic group. C double bond O, OH. C double bond O, OH. And suffix right here is oic acid. Oic acid. Now write down the name of this compound. First select the longest chain from the side of the functional group, and this is the functional group of the carboxylic group. Now methane, ethane, propane. Propanoic acid. 1 propanoic acid or propanoic acid. Both are correct. So what are the chemical properties of the carbon compounds? First is combustion of the carbon. When carbon is all allotropic form burn in the presence of oxygen to form the carbon dioxide and heat and light energy. When we burn any carbon, whether wood or coal or any other thing, then they will produce the carbon dioxide, heat and light energy. Carbon plus oxygen. Carbon burn in the presence of oxygen, then CO2 is released and heat and light is released. Addition reaction. Those reactions in which unsaturated compound like alkynes, they react with the molecule like H2, Cl2, H2O, etc. to form the another saturated compound are called the addition reaction. Addition means add. CH2 double bond CH2. If we react the ethene with the water in presence of H2SO4, then it forms the ethanol. CH3CH2OH. Ethanol. Hydrogenation. Hydrogenation, the process in which unsaturated compound react with the hydrogen in presence of the nickel and palladium catalyst to form the saturated compound. C double bond C and RRRR. This is the alkyl group and combine with the hydrogen gas in presence of the catalyst nickel and palladium and form the vegetable ghee or the saturated compound. This is vegetable oil is unsaturated and vegetable ghee is saturated. Addition of the hydrogen. CH triple bond CH. If we combine ethyne with the H2 gas in presence of nickel catalyst, then it forms the ethane. Unsaturated compound form the saturated compound. CH3 single bond CH3. Substitution reactions, in which an atom or group of atom of a compound is replaced by the compound is replaced by the other atom or group of atoms. Substitution means replacement, replaced by the other atom or group of atoms. CH4 plus Cl2 in presence of sunlight. Here from CH4 one hydrogen is replaced and form the CH3 from here and Cl combine here, and from one H from here and one Cl from here is replaced as a HCl. This is called substitution reaction. Oxidation. Carbon compound usually oxidized. Oxidation means addition of oxygen. Alcohol converted into the carboxylic acid. CH3CH2OH. This is ethanol. In presence of alkaline KMnO4 and acidified K2Cr2O7, and with the heat it forms the ethanoic acid CH3COOH. Ethanoic acid. Now we will discuss about the physical and chemical properties of the ethanol. Ethanol, physical properties. Pure ethanol is colorless. It is a colorless liquid and it has a specific smell and burning taste. It is soluble in water. Chemical properties of ethanol are: first is dehydration. Loses water molecule with the H2O. If we combine it with the H2SO, concentrated H2SO4 or Al2O3 in presence of temperature 443 Kelvin, then ethanol convert into the ethene. Dehydration takes place. Dehydration takes place. Reaction with the metal or sodium. Ethanol react with the sodium to form the sodium ethoxide. Here C2H5O, H is replaced from here and it combined with the N2Na and C2H5ONa. It forms the sodium ethoxide. Oxidation with alkaline KMnO4. Ethanol react with the or oxidized with the oxygen in presence of alkaline KMnO4 and form the ethanoic acid and water. Clarification. Esters are formed from the ethanol and ethanoic acid. Esters are formed from the ethanol and ethanoic acid. Ethanol C2H5OH, ethanoic acid CS3COOH. When react with the concentrated H2SO4, then it forms the ethyl ethanoate CS3COO, C2H5 and water. Combustion C2H5OH plus O2. It forms the carbon dioxide and H2O. Now uses of ethanol. Ethanol present in the alcoholic beverage such as beer, wine and whiskey, and it is used as an antiseptic for the sterilizing wounds and used in the cough syrup. Ethanol mixed with the petrol and used as a motor fuel. This mixture is called power alcohol. This mixture is called power alcohol. It is used for the preparation of chloroform, iodoform, ethanoic acid, etc. It is used as a hypnotic or it induces sleep. Harmful effect of the alcohol. If alcohol is mixed with the methanol, it is dangerous or poisonous in nature. It causes addiction from the habit. It damages the liver. Person loses sense of discrimination. Higher amount of the consumption of alcohol leads to the loss of body control, unconsciousness and even death. Alcohol as a fuel. Alcohol added to the petrol up to 20%. This mixture is called gasol. This mixture is called gasol. It is the cleaner fuel because it gives CO2 and H2O. It is pollution free. No pollution is caused by the gasol. It completely burns and gives rise to the carbon dioxide and water. Ethanoic acid or acetic acid and its formula is CS3COOH. Ethanoic acid is commonly known as acetic acid and its dilute solution is known as vinegar, which is used for the preserving food sources and the pickles. Physical properties of ethanoic acid. Ethanoic acid is vinegar smelling liquid. It is sour in the taste. Boiling point is high. Soluble in water. Acetic acid freeze at 290 Kelvin. Thus, in cold weather, crystallization of acetic acid may take place. That is why pure acetic acid is called glacial acetic acid. Now, what are the chemical properties of the ethanoic acid? Reaction with the metal. When ethanoic acid react with the metal or sodium, then it forms the sodium ethanoate. Sodium ethanoate and hydrogen gas is released. Reaction with carbonate and bicarbonate. Brisk effervescence is formed due to the formation of the CO2. When ethanoic acid react with the carbonate and bicarbonate, then brisk effervescence is released due to the formation of CO2. and it also forms the sodium ethanoate with the washing soda and baking soda, that is sodium carbonate and sodium hydrogen carbonate or bicarbonate. Reaction with the base CH3 COOH plus NaOH, CH3 COO Na plus H2O. Sodium ethanoate is formed here. What is the use of ethanoic acid? It is used for making vinegar and used for preserving pickles. Now, what are the esters? Esters are the pleasant, fruity smelling compound. They produce the good smell. They are formed by the reaction of carboxylic acid and alcohol. They are used in the making ice cream, cold drinks, perfumes, and in flavoring agents. Now, what is saponification? Process in which ester react with the sodium hydroxide to form the sodium salt of acid and alcohol is formed. Ethyl ethanoate react with the sodium hydroxide and sodium ethanoate CH3COON is formed with the C2H5OH or ethanol or alcohol. Detergents. Soap are sodium or potassium salt of higher fatty acids. They are the salt of sodium and potassium. Fatty acids are carboxylic acid containing 12 or more carbon atoms. Example, palmitic acid or stearic acid. They have the carbon 15 in the palmitic acid and in the stearic acid 17 carbon is present. Detergents are the sodium or potassium salt of sulfonic acid of hydrocarbons of alkene type. They have SO3Na group or SO4Na group. Sodium lauryl sulfate, that is CH3 CH2 whole square 10 CH2O SO3 Na plus. Now what is micelle? Micelle. When a soap or detergent is dissolved in water, the molecule associate together. Then the soap or detergent dissolved in water. Then the molecule associate together and these clusters are called micelles. Now what are the advantages of detergent over soap? Detergent works with the hard water but soap can no, and detergent also work with the acidic water. Detergents are more soluble, but the disadvantage is that they are not fully biodegradable and they are expensive than the soap. Talk about the cleansing actions of the soaps and detergents. Soaps and detergent consist of the large hydrocarbon tail with a negatively charged head. This is the negatively charged head. The hydrocarbon tail is hydrophobic or water hating. That tail is hydrophobic or water hating or water repelling. Water hating or water repelling. And negatively charged head. Head is hydrophilic. Head is hydrophilic, tail is hydrophobic. Head is polar, tail is non-polar. Head is water loving and tail is water repelling. Head is hydrophilic and water loving. This is the soap molecule. In aqueous solution, water molecule being polar in nature surrounded the ions and not the hydrocarbon part of the molecules. When a soap or detergent is dissolved in water, the molecule associate together and to form the cluster. This is called micelle. Tail stick inward and head outward. And in cleansing, the hydrocarbon tail attaches itself to the oily dirt. When water is agitated or shaken vigorously, the oily dirt tends to lift off from the dirty surface and dissociate into the fragment. This is the soap molecule, this is the negatively charged head and this is the tail. Here oily dirt covered by the molecule, soap molecule, head and tail. Tail cover the oily dirt and after the micelle formation, tail covered the dirt totally. The given and then it is agitated and shaken vigorously. Then This dirt will divide it into the fragments. This gives opportunity to other tail to stick to the oil. The solution now contains small globules of the oil surrounded by the detergent. The negatively charged head present in the water prevent the small globules from coming together and form the additives. Thus the oil dirt is removed. In this way we can clean the dirty cloth. Thank you.